Welcome to my Key Study Circle channel. In this video, we shall see how to create a 3D part and also prepare its orthographic projection using the Solid Edge 2023. We have the part given to us, so we are going to create a 3D part of this and then prepare its orthographic projections. So you can just see that this part can be divided into two halves, that is the semicircular half and next is the rectangular half. So the total length of this particular part is 110 mm up till the semicircle has been generated, and then it is having a depth of 72 mm, and then there are two through holes of diameter 26, and then the total width of this rectangular web is 70 mm, and the total height is 34 mm, and the circle is located exactly at the center, that is at 36 mm in this plane and 35 mm in this plane. So this is the details given to us, and also the web thickness is 20 mm in the upper half and 10 mm in the lower, 15 mm in the lower half. So with this details, we'll see how to create the part. So what we can do is we can select a front plane and draft the front view of the part till the semicircle, and then create the protrusion of this particular part to a depth of 72 mm, and then we can take the plane, that is the top plane, and generate this semicircle, and then generate the semicircle by doing the extrusion downwards, and then we can create the two holes by drawing the circles and then giving a extruded cutout. So with this knowledge, we'll see how to create a 3D model of this particular part. So we'll go to the solid edge and select the new isometric part. So I'll select the front plane, select the line option, and then let me begin with drawing the front view of the part. Let me begin with drawing the height, which is equal to 34 mm, and the total length is 70. And the distance or the thickness of the web towards the right hand side is 20. So this will be equal to 110 minus 55. So again, this thickness should manage with should match with this particular height. So the thickness here is 15 mm. The total height was 34, but this thickness will be equal to 20 mm. So I can give this as 34 minus 20, which is equal to 14. So now I've completed the front view of this particular first half, excluding the semicircle. So now I'll select this closed loop and then do the protrusion for a distance of 72 mm. So this is the front view of the part. So now let me take the top view and then generate the semicircle half here. So I can do that by selecting the circle option, and then I will place the circle exactly at the midpoint of this edge, which is equal to 72. So then the diameter of the circle shall also be equal to 72. So I have to trim the lower half, only then I can generate the semicircle. So for that, let me draw the diameter of the circle, then select the trim option and trim the lower half of the circle. So now the semicircle is ready. Now select this semicircle and then give the thickness of this semicircular flange to be equal to 14 mm. So now you can see that the semicircular flange is ready. So this is the complete top view. So now we need to create the through holes of diameter 26 on this semicircular region and also on this rectangular region. So for that, let me select the circle option. So it is exactly on the center of the semicircle. So if I just move the cursor on the semicircle, I'll be getting the semicircle center. So let me draw a concentric circle of diameter 26 mm and then take the circle option again, and then on this midpoint and also on this midpoint. So you can just see that I'm getting the dotted lines, which is indicating the midpoint of both the halves, that is 72 and as well as 70. So let me draw the circle here, and this should also have a diameter of 26. So now let me select both the circles and then go for extend type and select through all and then select the downward direction. So this circle is generated. Similarly, select through all and indicate the direction downwards. So the circle is created. So this is the part. So now let us just look at the dimensions if it is correct. So as given in the problem statement, the total length from this edge till this edge, it is equal to 55. So this is correct. So from this edge till this distance, it is equal to 110. So we'll just modify this to be equal to 110. Then we'll select the distance again and then check out the distance between this and okay, so the total length here is 70, so no need to do the over dimensioning. So we'll select the top view now. So this width is 72. So this has to be 70 because it was 70 here. And now we'll just check out with the circle. So for that, select the distance between option. Select the circle so that you get the midpoint of the circle and also this plane. Okay, we can just check out the dimensions in the orthographic projections by marking the center, and then if there is any error, we can come back and rectify that in the part. So now this is the 3D model that has been generated. Okay, so we'll create the orthographic projections of this particular 3D part. So first let us save this. So now select the new isometric draft, modify the sheet properties, change it to A4, untick show background, click as save defaults, click OK, fit the sheet to the screen, and in the home window select view wizard and select the part, click open, ensure the scale is 1:1. So this is the front view, the corresponding side view, and this is the top view of the part, and this is the isometric view which is not required for us. So we'll complete the orthographic projections in the standard procedure. So select a line of 0.13 mm thickness, draw the XY line and the X1 Y1 line. To get the side view, I require a 45-degree line. So draw the 45-degree line from the point of intersection. So let me complete the front and the top views. So you can just see that the circle will not be visible in the front view. So the dotted line indicates it is a circular hole, through hole. So that is why the circular hole, which is a through hole, is shown by dotted lines throughout the thickness of this rib. Okay, so this is the same even for the hole on the rectangular face also. And this is the lower portion of the rib which is not seen on the top, so that is why it is dotted line here. So now we will take the horizontal projector, intersect the 45-degree line, and then take up the side view and adjust the position of the side view. So now these are the two extreme projectors. So now select the side view and select the move option. So take one corner of the side view and place it on the end point of the projector. So you can just see that the side view is adjusted appropriately. So now we'll take the line option again, draw the projectors from the circle. So it has to be a tangent. You can just see that it is intersecting properly. So you can just use the extend to next option and extend this line to the next circle also. So you can see that it will become a tangent because they're all along the center. So now go for the dimensioning. So in the side view, you'll get to know the height of the part, which is equal to 34 mm, and also the total depth of the part, which is equal to 72 mm. And then here, 72, the depth in the top view, and this is 70. So from this distance till here it is. So go for the smart dimension. So we'll take up the distance here. From this point till this point, it is equal to 55 as shown in the part diagram. And then we need to have the distance between this edge and the place where the semicircle will start. So for that, let me take the center. So here in the sketching window, you have got an option to mark the center. So this is the center mark in the annotation. You can just see that you get the center of this circle and then center of this circle. So now go for smart dimension. So this is exactly equal to 110. Correct? And then you need not have to show the diameter or the radii of the semicircle because it is understood that it is obviously equal to the dimension, that is 72 mm, that is the side dimension of this particular flange. Correct? And then you can just show the thickness. So the thickness of this is 20, and since it is 34, 34 minus 20 is 14. So this you do not have to show it here again. It becomes over dimensioning. So it is not required for us. So I guess all the major dimensions are shown. Okay, we need to show the diameter of the holes, which is very important. So equal to 26, both the circles. So 26. So this indicates that they are the through holes. So no need to mention that it is a through hole, correct? And then we need to show the distance of this circle, the center of the circle to the midpoint. So for that, go to the IntelliSketch and select the midpoint relation. Click OK. So you get the midpoint of this line. So let me select this distance between. So probably, yes, this is the midpoint. This is the midpoint. So it is equal to 36. So it is correct in the part also. You need not have to show this. 36. Let us just verify this. Again, the same circle distance and the midpoint here. So select the distance between, select the center of the circle and the midpoint of this line. So which is equal to half of 70, which is 35. So this dimension is correct. So the circle is located exactly at the center of this rectangular plane of 70 cross 72. And then also the center of the semicircle and this circle coincides. So they are concentric. I guess we have shown all the necessary dimensions. So the projectors of the side view from the front view is not shown. So let us complete that. So this completes the projection. Now let us indicate the directions of the projection lines by selecting the leader property from the annotation. Change the color to black and ensure it is a filled arrow. Click OK and then show the directions of the projectors. So these are all downwards. These are all the projectors drawn from left to the right hand side. So the direction has to be shown in this manner. And here these are all the projectors taken from down to up. So this is the direction. So with this we complete the indications of the direction of the projection lines. Select the annotation text and change the font style to Times New Roman. So label the planes, that is x and y, x1 and y1. And label the views. So this is the front view, this is the top view, and this is the left side view in RPP. You can show the angle 45 degrees. So this completes the generation of the orthographic projection of the given isometric part. So we have created the isometric part in the 3D modeling part of the solid edge software. So this is the 3D model, correct? And then we have prepared the orthographic projection of the 3D part using the draft. So with this we complete the generation of the